Proposition 8, Book 2, Euclid. If a straight line be cut at random 4 times the rectangle contained by the whole in one of the segments plus the square on the other segment will be equal to the square on the whole in one of the affirmation segment and the affirmation segment taken as a straight line. So here is our given straight line cut at random, and what do we want to prove here in this proposition is that 4 times the rectangle contained by this straight line that is cut at random plus one of the segments plus the square on this segment, that is the left one, segment, will be equal to the square on the whole and the affirmation segment taken as a straight line. So here is going to be our affirmation segment, that is this one, the blue one, and we're going to take this plus this as a straight line. It's going to be the whole. So here is the same thing, I just passed with colors. So let's get it started. The first thing that we are going to do is to make our square. Okay, so let's get it started with our square. Here we're going to make it, as we know, with right angles, because we need to do a square. We need a line in which the 4 sides will be equal, and we need the right angles. Okay, so now we are going to make here the diagonal. Okay, let's make here the diagonal here. Fine, this is a diagonal, and you're going to make it from a point out on this line, a line parallel to this one. Okay. And also from a point out on this line, a line parallel to this one. And they're all parallel to each other. Okay, they're all parallel to each other. Great. Now, as we always do in the propositions, we're going to make here this one parallel to this one. Let's extend. Here, we're just extending the line. Okay, and also down over here, we're going to make from this one, we're going to make it this parallel. Okay, so now we made this one parallel to this one parallel to this one. Okay, let's continue. So fine, we have already our figure, so let's not start getting with our proposition. First of all, what we are going to do is to prove that this is a square. We're going to prove that this is a square, and we're going to prove that these 4 are squares, and that these 4 are equal to each other. So let's get started with it. Okay, so let's get started. We have here our square, because we did a square, and we have here a triangle. Yeah, and this triangle has the 2 sides equal. Therefore, we can conclude that the angles at the base are equal, and we can conclude that this is an isosceles triangle. Therefore, the angles at the base are equal. Well, so we are going to have here 2 parallels. We are going to have a straight line falling upon this parallel, and we are going to have this angle being equal to this one because it's the exterior being equal to the interior. Great. We're going to have the same thing here. We're going to have 2 parallels. We're going to have a straight line falling upon. We're going to have exterior being equal to the interior. We're going to have this one being equal to this one. This one equal to this one. This one equal to this one. This one equal to this one, because 2 things equal to the same thing equal to each other. Well, As this is equal to this and this is a triangle, we are going to have that this is an isosceles triangle, this side is equal to this side. And as this is a parallelogram, we are going to have that the opposite sides are equal, therefore we're going to have four sides equal. As we did this, a right angle in the beginning, remember we did a right angle. So we are going to, we are going to have that the opposite side, the opposite angle is equal. Here we are going to have two parallels. We're going to have straight line falling upon. They're going to make they need to make two right angles. Sorry, these opposite. Okay, we have a square. And now this one. Let's prove that this is a square right now. As these are, how was it? I think it was vertical angle. I don't really remember the name, but they are going to be equal to each other. Opposite equal to each other, vertical equal to each other. I don't remember if the name is vertical, but equal to each other, and the opposite equal to each other. We're going to have this one opposite to this one. Also, we are going to have two parallels, one falling upon. We're going to have this right angle, this right angle. Also here, this right angle, this right angle. Why? Because two parallels falling upon need to be two right angles. Sorry, need to be two right angles. We're going to have this right angle. Okay. So now let's prove. So now this one is equal to this one. Sorry, this one is a square. This one is a square. Now let's prove this one is a square. How are we going to do that? We can say, for example, this is a straight line. This is not a straight line falling upon. They making adjacent angles equal to right angles. This one can be a right angle. Now so here we're going to have these opposite angles equal to each other, and also here because two parallels fall upon. It's going to have the same thing here for our squares. Great. Having the four squares, we are going to have that. As for our squares, we can now let's prove that they are equal to each other. Oh, they are equal to each other. How are we going to do that? This square is made by this side, and this and this and this. And this square is made by this side. This square is made by this side, and all those sides, and this one also. This square shares with this one, this side. This square shares with this one, this and this side. As this one shares with this square, this side, and we know that all the sides are equal, therefore this is going to be equal to this because they share the same side and all the sides are equal. Therefore, they are going to be equal to each other. Also this one and also this one. We are going to have the four equal to each other. Okay, now that we have already the four squares equal to each other, and we have this being a square, let's continue. Now let's prove that this. Okay, no. Now let's look at this. Let's look at this parallelogram over here. This is a parallelogram. Let's look at this one. What are we going to have here? We are going to have that they are complements. Yeah? Here we're going to have they being complements. Okay, so you have these two complements. Okay, having them complements, we are going to have that they are equal to each other. Okay, so let's look at these two now. These two are rectangles and they have the same base. I mean, they are not in the same base, but the same base. The base are equal. The base are equal bases. And they are in the same parallel. Therefore, they're equal to each other. As well, these two are in the same parallel and they have equal bases. The bases are equal and therefore they're equal to each other. We're going to have this one equal to this one. This one equal to this one. As this one is equal to this one, we will have that this one is also going to be equal to this one, and this one is also going to be equal to this one, and this one equal to this one, and this one. Because two things equal to the same thing equal to each other, we're going to have they all are equal to each other. So this one is equal to this one, and this one is equal to this one. Okay? Great. So let's, for example, add this one to all of them. As we know that the four squares are equal, let's get it started. We are going to have this plus this square plus this rectangle. This whole will be equal to this whole that will be equal to this whole, or we can take this one plus this one, and this whole. Here, as we know, the other squares are equal, and we take this square already for this rectangle. Let's take this one to this one, so we don't really confuse here. Let's take this, this, and let's take this one. Let's say, this one will be equal to this plus this, and this whole. That is also going to be this plus this, and we will be able to say that 4 times this whole will be equal to what? Will be equal to this plus this plus this plus this, right? So we can see here that this plus this plus this plus this is what we call random, right? Here we are going to have a random, yeah? So, as it's a random, we are going to have that. We can conclude that. We can say that 4 times this is a rectangle will be equal to the random, the whole random, okay? Great. Let's see here that we have already, what do we have already? We have this as this rectangle being equal to this whole random. Sorry. 4 times this rectangle being equal to the whole random, okay? Let's add this square to both sides. Let's add this square to the 4 times this rectangle and the random. So we're going to have 4 times this rectangle plus this square equals to the random plus this square. But look what we have here. This square is the square on this segment of the straight line. And this square is the square contained by this one. Why? Because we're going to have this square contained by also this one, because these two are equal, because there is a parallelogram. It is a parallelogram. Opposite sides equal. Also, here's a parallelogram. Opposite sides equal. We're going to have this is contained by this straight line. Okay. And this rectangle, actually, if we see, is a rectangle contained by the initial given straight line plus one of the segments. Can you see that? This whole plus one of these, because this is a square, this side is equal to this one. So this rectangle is the rectangle contained by this whole given straight line plus one of the segments. Whoa! Now we added already this one to this whole, and the whole how is it? Random. We added this one. But look at this. The whole random plus this square is equal to the whole square. But the whole square contained by what? The whole square contained by the given straight line that it was cut at random plus the affirmation segment taken as a straight line, because we took it as a straight line, this whole. Now we can conclude our proposition saying that if a straight line be cut at random, 4 times the rectangle contained by the whole and one of the segments plus the square on the other segment will be equal to the square on the whole, and and the affirmation segment taken as a straight line. Okay, so that was proposition 8 of book 2.